the impression that the first thing we needed to do if we're going to talk about FHIR and RDF is to talk a bit about how FHIR came to be. Um, so puns everywhere as usual. FHIR evolved out of what for me doesn't seem like that long ago, but I realized it's 30 plus years ago now. And a group called Health Level 7 was formed. It came out of the OSI 7-level stack, where the 7th level was the application layer. And it was pretty ambitious for them to say we're on the application layer. I mean, it's the semantics of communication back then. Uh, they V1 never happened, but between 1987 and 89, the second version came out. But they discovered before we start talking about the application layer, we have all those other layers underneath there that we need to do. This was before TCP/IP was readily available. This is while you were still having the wars on network connectivity. You had to decide whether you were doing NetWare or Microsoft or other stacks, etc. So HL7v2 spent a lot of time just talking about formats and structures. HL7v2 was wildly successful. And it was wildly successful in no small part because it wasn't that hard to do. It turned out that you could claim compliance without doing a lot of work, which meant that vendors said, well, we'll go ahead and say we're compliant with this, which in turn led consumers, the clinics and what have you, as they put out RFPs to say, well, let's ask this question about HL7, which caused more vendors to do it. And it snowballed. But the problem with version 2 is it was terribly underspecified. But the good thing, it's widely in use today. It's still one of the primary communication mechanism for healthcare records. This is just a sample of a V2 record. They actually have their own formats. These days they use XML and TCP/IP, but the original spec actually had a layout for this. This is a couple of observations. Your body height and weight. It looks understandable. The thing is the codes that go inside. See, I guess the cursor isn't going to go here, but I have this wonderful arrow. The, the information that goes inside here, the fact that we're talking meters and kilograms, the fact that we're weighing body height or doing body height and body weight makes sense to us. When it comes to computers, you got to pick what went in those slots. And I worked for a company that built HL7, well, built healthcare computing that included HL7 records. And we charged $90,000 to configure 2 of our own computers in 2 different institutions to talk to each other using the HL7 standard. It was a great moneymaker, but that was also kind of the problem. So Health Level 7 said, we really need a standard where we lock down the semantics and we lock down what we're talking about here. And that became V3. One of their mantras was optional is a 4-letter word. Everything has to be locked down and decided. As they say, they developed a very large model. They originally had a wonderful model that the last version of it required a huge printer. We actually bought a special printer just to be able to print the UML for the model. At some point, they had this great idea of the Unified Service Action model where they built kind of a meta model. This isn't a model of healthcare. This is a model more of a philosophy. And it's entities, roles, relationships, and what have you. And so they folded this complex model of healthcare into this meta model and then put the little details about all of the different names of the entities, patients, institutions, etc., into the terminology space, which we never managed very well. And probably slightly out of sequence, but it's kind of interesting. The other thing that happened to V3 is the HL7 mission statement. This is fun to go back and use the Wayback Machine and look at all the websites there. 2001, the mission statement was involving information system interoperability and sharing electronic records. The domain of discourse was information systems. And so they talked about records and codes and fields, and healthcare was secondary because the records were about healthcare. They had to talk about healthcare, but they weren't modeling healthcare. They were modeling records that were exchanged between information systems. By the time we reached 2008, they'd gotten a little more ambitious, and they were talking about knowledge transfer. Right. No, I take there was a slide in the middle, so this is where it evolved to actually. The systems disappeared, and they started talking about providers, vendors, patients. One of the problems they ran into that was huge is they made this change to this mission statement without really understanding its ramifications as far as their models and ontology and semantics went. And so their semantics still talked about things being codes and records and what have you. And all of a sudden you had this interesting mess where you had a patient is a record that covers this, et cetera, et cetera. It led to a fairly well-known philosopher named Barry Smith, whom lit into HL7 in the 2000s. He wrote a blog called HL7 Watch, where he went through and just found all of these philosophical and semantic errors in their models, and challenged the community quite a bit. One of the things here, this is a fairly late post, but it's kind of interesting. This is talking about CDA, which is a derivative of the V3 spec. It says that it feels like it was designed by people who haven't done much information designing in their career. People who are experts in the domain, but not in information systems, etc. Very interesting, and I'd recommend taking a look at that blog. If nothing else, Barry has a wicked sense of humor, so it's kind of fun. By 2019, the mission statement had changed considerably. Standards that empower global health data interoperability. That's starting to get more in the area of knowledge graphs, and although I haven't heard the term AI for years, in the 1980s, that was the big thing. It's interesting to find that emerging again. So HL7v3 was elegant. It was terribly abstract, very philosophical. Training courses became one of their major products, how to understand what we're talking about, and even more training courses on how to implement what we're talking about. And interestingly, especially vendors weren't really interested in investing large amounts of money. There was a proven payback, which there wasn't. And in fact, until very recently, interoperability was something that as a vendor you didn't really want. We wanted to be able to charge those $90,000. We didn't want somebody to be able to just configure our system to do what we wanted. But it started, we began to realize that it's not going to go. V3 isn't going to work. So they started a project called Fresh Look. It was kind of under the covers, and for a couple of years it was just a small community of people tinkering in, well, a back on blogs and wiki sites and other things, putting together something called. One that stuck was the Fast Healthcare Interoperability Resource 2014-2015 era. And since then has become the de facto standard for the exchange, representation and exchange of healthcare information. It was interesting. We were talking with Microsoft and looking at their Azure website, and you now have on the buttons of all the different things you can configure in Azure, set me up a wiki site, set me up a server. You can click on set me up a FHIR server. That's one of the options. The Apple phone, if you download their health app, it uses FHIR as representation to acquire clinical data from your institutions and to communicate it. It's basically become the standard. This is the home page of FHIR. I don't have time to go into a huge amount of detail, and in fact, I'm probably going to be hard on time as it is. But the URL is there, and you can go take a look at it. It's very approachable. A note down at the bottom there. This is the stable version that they're locked in and people are using. There's a continuous build site out there that most of the time is up. Jenkins takes a good care of it, but having developed on the site, I've taken it down myself a couple of times, but it's the leading bleeding edge. So first off, FHIR is a really good acronym. And if you've been in this business as long, it's technology. I don't think the OMG has really latched onto this yet, but the FHIR is sort of kind of competing with the OMG. It's entirely its own open source development stack. It does not use UML. It uses a modeling language that's a little lumpier than UML, but it's open source. It's open community in a very radical way. They started out using Skype as a communication mechanism. This was a couple, 3 years back before Slack and some of those arrived. And Skype had a limit of 120 people on a conversation. And so they switched to Zulip because there's frequently more than 120 people online. It's really amazing because the father of FHIR, Graham Grieve, seems to be available 24 hours a day. You can go out on Zulip day or night and post a question and you get an answer within 20 minutes. I think there's more than one Graham is the only thing I can figure out there. Right. So it's a technology stack that's turning out to be pretty dang useful because it's completely open source. All of the software is available for download and tweaking. Okay, the second thing it is it's a platform built on these standards, and that's what's called the FHIR core. That's the definition of the healthcare resources that are out there. FHIR core, I'll get to it in a second here, but if you go look at the FHIR specification, what you realize is we'd said, well, if you start looking down the record, an observation or something, and there's only 2 fields that are actually required in the entire spec, and you say, how can this be an interoperability standard if there's only 2 fields I need to put in? We'll talk about that a bit more, but it's not an interoperability standard out of a box. It's a platform for developing interoperability standards. It's also a set of what are called profiles that actually are interoperability standards built on FHIR. And finally, and I think the key thing is whether it's just the right time, the right place, the right people, it's a very dynamic, involved community that's building this stuff. And it's the community that's really made the FHIR successful. They have FHIR developer days that occur twice a year now. You pay a fair amount to go there and rub shoulders with the people that are there's a wealth on how things are done and how they work. And so I think that really makes it work. So, and just a word of warning, they claim to have addressed every possible pun you could make in FHIR. They're actually, I think there's an offer out there right now that if somebody arrives at a pun involving FHIR that hasn't been used yet, there's 50 euros or something for the developer. But so be careful. It's very hard to talk about FHIR without doing that here. Okay, one of the reasons it works is FHIR has a core target audience, and that's people that develop software. That is their primary community. It's very interesting. I got in an argument with Graham early on when he was putting it out there because I was quite a proponent of XML schema, XML being the, this was pre-JSON. JSON's pretty recent. And he said XML schema is just too hard for the average programmer, which I took umbrage to, but I think he was right. There is an XML schema for FHIR out there now, but he actually he put out templates, something so you could go to a web page. You say, I want to create an instance of a clinical observation. You can just download the XML, fill in the blanks if you want to. So with no software development at all, you can create a compliant FHIR record. And because it uses RESTful architecture, if you know how to do a simple put or a post on a website, you can put this FHIR record out on one of their test servers. You can query it, you can integrate it, so you can get started very quickly, and it's not hard to develop. The other thing that makes it work, it's something that people complain bitterly about because it's very hard to describe, the 80-20 rule. It's basically, we're going to work on things that matter to most of the community. We're going to make the edge cases possible, but we're not going to spend our time on them. This comes out from lessons in V3 where they tried to model everything, and it turns out you can't do that. Models are by necessity restrictions. They're abstractions, and models are about what you don't pay attention to. HL7 V3 tried to pay attention to everything, and they spent years and years and meetings going down into the minutia. It's kind of fun if you look at just their definition of what a blood pressure measurement is. Because it turns out sometimes, I guess it matters what cuff you're using, and it matters whether you're seated, it matters what you did before. I mean, there's all these different variables you can record, and if you want, you could spend a whole day talking about the parameters that could go into a blood pressure measurement. One of the things FHIR said is we're not going to do that. If 80% of the healthcare systems out there aren't recording it, we'll give you a way to do it through tag values, but we're not going to spend time modeling it. Okay, this page is here, and these slides will be uploaded here because this wiki page keeps track pretty much of everything you would ever want to know about FHIR. It's been cut off now at the bottom here. But if you want to learn more, if you want to go to tutorials, if you want to connect to the Zulip site, whatever you want, this page has it on there. So to dive into it, an example observation in FHIR, an observation being some measurement, some clinical measurement that you're recording about a patient. This is the first page here. An interesting thing about this web page, I said FHIR is model-driven architecture. I used to say done right, and people corrected me, but it is model-driven architecture that works. This entire web page, the text is snippets in an XML document, but the page itself is generated from software. It's a build, and the entire FHIR website is built from an ANT process of all the dang things. And this is the first page of the description of the observation. A key thing here, I think one of the takeaways, is the amount of metadata on here. Not directly about the model, but what the model's used for, why it was built, who's responsible for it, what its status is, security categories, all sorts of interesting information that when you're doing data models you normally don't get in, and a lot of things that you don't find in the UML modeling language these days. Let's see, the next thing, okay, I put profiles down here so I'd remember to talk about it. Profiles, the FHIR model itself, and let's see, I'll move up to here. This is just a little bit of the observation model. So an observation, it says you can have 0 or more identifiers. You can have 0 or more references to care plans, recommendations, requests, etc. that the observation is based on. It can be a component of another thing. It goes down quite a ways. But the key is as I said, this is 0 to star. You don't have to have any of those. What a profile is a profile takes a FHIR observation and it constrains it. You can take the cardinality of 0 to star and you can say, I'm going to make that 1 to 1. I want exactly one of these. You can take a 0 to star and make it 0 to 0. In our model, You can't put this in here. You can say, well, this could be numeric or ASCII. In our model, it has to be a number. In FHIR, it might say you can use any code system you want for lab codes. You can put in the profile the specification that says we want to use LOINC, laboratory identification codes, as the profile. And so you can take the FHIR specification and create a set of rules that in your community gives you interoperability using constraint language. And the constraint language, by the way, derives very much from the OpenAIR work. OpenAIR being, if you're familiar with it, it's used quite a bit in the EU and everywhere pretty much but the US actually, that uses a constraint-based language here. So like profiles, we have the content itself. FHIR, as out of the box, or when we first got involved in it, has two representation formats. The first being XML, the one that was in great use when we started doing FHIR, and frankly nobody uses anymore, but there you are. And so this is just a sample record. I pulled it off of the samples on the website of a FHIR observation. Let's see, where are we here? Interpretation. Okay, the interpretation is a raised serum creatinine, so this must be, yeah, this is an example of a serum creatinine, micromoles per liter or whatever. Anyway, just a sample of an observation in FHIR pulled off the website. The one that everybody's using or was using these days, I guess YAMLs now are the big thing, but a lot of it's in JSON. They have automatic rules for representing FHIR in XML and JSON. And all this is done by their underlying software. You can put either XML or JSON into the FHIR server and pull either one out. Another interesting thing is FHIR is defined in FHIR. If you learn how to use FHIR to create an observation, you also know how to use FHIR to create a brand new model, because structure definition is just another resource inside FHIR. For obvious reasons, most servers don't allow you to change structure definitions because that's kind of damaging, but structure definition is the meta model of FHIR. This I mentioned earlier that the FHIR website is built automatically. FHIR is out on GitHub. We finally got them off Subversion, or I shouldn't say we, but they got themselves off of Subversion. Openly available. You can go out and clone it, and if you've got Java and Ant and a basic build stack, run the publish.sh. It rattles for about 20 minutes, and assuming that what you cloned doesn't have an error introduced by a developer like me in it, when the build finishes, you can point your browser at the published directory that you built and pull up an exact duplicate of that FHIR website I showed you earlier. So you can look at how they build what they build, and that's pretty interesting. As I said, it isn't a solution to interoperability. Do people know when I say BDFL? How many Python? Not a lot of Python developers. There we go. Well, Python, Guido, I don't even remember his last name now, was the creator of Python and became kind of the ultimate arbiter as to what did or didn't go into the Python language. So they had a whole community of people, but in the end it was Guido that decided went in, and he was known as the Benevolent Dictator for Life, or BDFL. Now what's interesting is Guido got mad at his community about 6 months ago or a little longer and resigned, which is little distressing. Anyway, Graham Grieve is the BDFL on the FHIR community, and this is a blog, a very active blog he has out there that's very interesting. And one of his statements here I think is terribly important. He says, folks say FHIR is going to solve interoperability problems, and he says, nope, it's not going to. He says, what I've done, or what we've done collectively, is build a technology and a culture. He says there's a lot of reasons we can't be universally prescriptive. There's too many contexts, too many communities, and what have you. But a key thing is that if you can come up with a common way to say things, if you have those 0 to star slots, so if you want to link an identifier to something else, if you want to put in observation code, then if you want to have interoperability, we have the descriptions necessary that you can actually make it happen. So that was FHIR, and a little longer than what I intended, but there we be. The other part of FHIR is an interesting thing. I'd mentioned the two formats. Well, there is a third one out there, which is FHIR and RDF. RDF is a third representational form for FHIR. And maturity level 2 means that there's a couple of implementations. We're kicking the tires. There's quite an interesting path about how proposed models, proposed definitions make it into FHIR standards. And RDF is out there as a proposal for a possible FHIR standard. What it's got in it is how to represent FHIR in RDF and the reverse. It's got a package in there that converts the FHIR metamodel into shape expressions. Because if you go out to the regular FHIR website, or not regular, if you go out to the FHIR website, for the XML, they have a combination of XML schema and schematron that defines fairly precisely what the XML has to look like. And the XML schema and schematron are generated from the FHIR model. For RDF, we're using the shape expressions language, which is a description of, it's a schema for RDF. We would have called it RDF schema, except that was already taken for something that wasn't a schema for RDF, so there you go. I'm going to talk about the other bit here, which is the FHIR resource catalog, which is something that I find very exciting. So if you go out to the website, if you go over to the examples, over on the right-hand side, you'll find XML, JSON, and Turtle. Interesting issue when you're dealing with RDF is because you've got RDF as an abstract syntax, and then you can have RDF XML, you can have N3, you can have Turtle, there's dozens of them out there. What you're going to find on the FHIR website is sometimes Turtle is used as a syntax, and sometimes it's used as a placeholder for RDF itself. So in this case, it's actually, you can go to the Turtle representations. Just a crosswalk, not a lot of time to go into it, but this is a JSON representation of a FHIR observation. This is the RDF equivalent. One of the things that's confusing, if you know JSON, the little open square brackets is the start of the list. In RDF, it's a blank note. It's if you're familiar with RDF, blank nodes are one of the, I view them as kind of a necessary evil, but evil nonetheless inside RDF. They're things you don't want to name, but it turns out you often do want to name them, and there's endless battles on the W3C site about what they call scholemization, or how can we give names to things we've decided we're not going to name. My answer is decide to name them, but they don't go there. Anyway, so for instance, this is the URL for a FHIR observation status. It references a blank node whose predicate is FHIR value and whose object is the literal final. And that corresponds to status final here. So one of the questions is why those blank notes? If you look at this previous one, an RDF aficionado says, oh my goodness, everywhere I go, I've got this blank node with a FHIR value inside it. Why is it not just status final? One of the requirements that was put on the RDF package is that it had to be what they called completely round-trippable. You had to be able to take a FHIR structure definition in any format or abstract format, take it into RDF, and then be able to replicate exactly what you had to begin with. One of the things about a FHIR structure definition is that everything inside FHIR is extensible. I mentioned that you had the 80-20 rule and they had tag values where you could do the 20 if you needed it. Well, they have taken this to an extreme. And so it turns out that the Boolean data type actually is extensible. If you want to, you can, in a profile, say, I'm going to extend a Boolean data type and I'm going to add a certainty value to it. I mean, I'm going to create a little specification that says I have a way of putting a certainty inside a Boolean data type. So the key is normally, and in fact, I almost always, it's just going to be a straight Boolean. It's just going to be XSD Boolean. But because we have to be round trippable, we have to be able to deal with a situation where we've got Boolean with a certainty extension. And that requirement has led to a lot of really entertaining things that at some point we may yet come up with the way around. Another thing in the RDF that's important is if you're dealing with XML or JSON, it's a rooted document. There is the document. There's the outermost node, and it's a tree structure. RDF is just a collection of triples. And so if you get a collection of triples, you don't know where to start. You don't actually know what the document root is. This is an RDF problem that the W3C community has been successfully kicking the can what is it, ahead of themselves for ages, as far as putting something into RDF so when you get graph, you know what the root node is. They never did that. So in FHIR, we've gone ahead and we've created an additional node, node role, and it's got only one possible value now, which is tree root, which then says that this diagnostic report F207 is the root of a graph. And that's just something you have to put in here so that you can reproduce this outermost brace over here. The other thing that RDF, question, did you? Well, that's a really good thing. That's one of the things we take advantage of, is it's a collection of facts. But to do the round trip, to be able to replicate this in JSON, or to be able to replicate a thing called a resource, we need to, and resources can be embedded inside of other resources. We still need some way of identifying the document or the outermost node to be able to reconstruct it as a tree. And okay, the other thing, RDF came out of a Lisp community, and they very much like their lists. And so if you look at the RDF collections, you have the first and the rest, the cotter and the cooter, if you're from the old list days. And they represent collections as lists. So you have RDF first, you have an element, and then you have RDF rest, which is another list, and you recurse down as with Lisp, and you do first next until, I don't remember whether it's first grounds out at nil, RDF nil, or next, but it's a nested structure. This is neat for Lisp people. If you've ever tried to do a Sparkle query against RDF where they have a list inside, it's awful. So there's all sorts of different proposals on how to do sane lists out there. None of them, to the best of my knowledge, have taken as of yet. The RDF group decided to just put a FHIR index inside here for ordering. So there's no statement. The type is integer, and it's just done in integer order. But so that's another bit that shows up there that you're not going to find in the JSON. Another thing that this is a frustrating thing about HL7 actually, is when you get to a concept identifier, a link into an ontology, they specify you put in a URI for the code system, you put in the code, and you put in some sort of display so that human beings know what you were talking about. What they don't do, however, is specify a URI for the referent itself. And in fact, you as a consumer, have to be clever enough to figure out, well, how do I take this system in this code and produce a URI that references the SNOMED CT concept of radiology? A seemingly obvious answer would be, well, don't you just concatenate them together? Well, do you put a hash or a slash between them? That's the first question. But the other thing is SNOMED has formally defined a URI scheme, which is wonderful. They say this is what our URI should look like. And they've said the name for SNOMED CT is going to be snomed.info/SCT. The name for a SNOMED CT concept code is going to be snomed.info/ID/code. This is knowledge you have to have in order to be able to do this. In the FHIR spec, we decided, or the RDF spec, we're in the RDF world, we're going to just go ahead and say we know how to do this. And so we put in an additional field, and it's the SNOMED identifier. Now, if you're familiar with RDF turtle syntax, A means RDF type. It means an instance of. This is philosophically troubling for some people to have a record, and to say that this diagnostic report is an instance of something called radiology in FHIR, or in SNOMED. We can talk more about that later, but it's something to keep in mind. But anyway, so we put in the instance identifier. When you have references to other resources, FHIR did not actually have the type of the referenced resource. They kind of counted on you being able to parse URIs, which is a really bad example. If you've ever read Fielding and what have you, URIs, while readable, should never be computer parsable. You should always be able to use links to get to where you're going. So we put in an additional field that gave us the resource type and link, kind of down in the weeds. But anyway, that's just another difference you're going to find in the FHIR RDF. Let's see, where did I go here? Oops. All right. And then the final thing, in the bottom of each FHIR resource that we define out there, there's a little ontology header. And this is a strange thing. This was developed by the OWL community, and OWL needed the notion of a document that contains a set of ontology definitions. And there wasn't such a thing. This is another place where the RDF community has been slacking off a little, is how to describe a collection of RDF. Named graphs is starting to get there, but there still isn't any real model for it. So at the bottom of the resource, we put the ontology header that imports this. We'll talk about it in a minute. And what this makes it you be able to do is to pull FHIR resources into something like Protege or Reasoners, which is terribly important. This is just showing that there's a couple of different resources out there that are a couple of different servers that are out there. A key thing to note on this is that a couple of the major FHIR servers, if you know about them, Happy being probably the most well-known these days, which is an open source FHIR server stack, doesn't at the moment support RDF. It's not that they don't want to, it's that there has to be enough demonstrated need that it's cost effective for them to do it. It's my understanding that somebody is working on this project right now to get RDF implemented in the Happy stack, but you won't find it there right now. As an interim, there is a little JSON to RDF utility. It's one directional, but you can pull JSON from any FHIR server and run it through this little Python converter that gives you the RDF. I use that for a lot of the secondary projects I've been doing with FHIR RDF. Okay, the other interesting thing, and this is a part that I think is really important, is that in order to pull a set of RDF of a FHIR resource into Protege or into a Reasoner and work with it, you actually need to talk about what the various predicates, what the class names, FHIR observation, the predicates, observation ID, whether they're object the two types of predicates, objects versus object classes, data classes, or annotation classes. You need to be able to describe all of the URIs that you've got. If you just pull FHIR RDF into Protege without this extra definition, it thinks everything's an annotation resource. It thinks everything's our annotation, and you can't go anywhere with it. Definition of all the predicates in FHIR, all the class names, and so like condition is a class name. It's a predicate called a date, abatement in time, endpoint address. Basically, every node that occurred in FHIR we need to define. It was called FHIR ontology for a while, and it turned out to be terribly confusing because this is not a model about patients and specimen. Ontology of FHIR records. It's a representation of all the. Okay, right. So just noting you can, and it's pretty useful as a model there. I'll get back to it in a second, but what I wanted to say, one of the really exciting things about it is that it is it's a draft part of the FHIR standard, which means we've got URIs out there for pretty much anything you can say in the clinical space. We've got URIs that are standard and describe all the elements that occur in documents. And that is really exciting. I view it kind of as the Dublin core of clinical data, if you want. Dublin core being a resource that allowed us to describe strange things like titles and authors and really basic stuff. Okay, there's also the shape expressions, which is the RDF schema. As I said, it's because RDF schema was used for something else. Also, it's a very dangerous act. You start thinking about how you can use it in any context, but make sure you use it safely. Yes. And it's automatically generated for all of the FHIR R4 resources. One of the things we don't do yet is encode the information in FHIR profiles, but you can use it to validate an RDF record to see whether it conforms to the FHIR specification. There are conformance checkers out there. This is a couple that are there. There's a Python one out there now too, which I'm the author of. It's called PyShex, and as a plug, PyShex is actually being used as a validator for Wikidata. It's one of the good thing about RDF is anybody can say anything anywhere, but the bad thing is you can. It's if you have something out there, if you pull a record that says this is a record of a person, and you find it has a first name, there's no guarantee it's got a last name. RDF is just a set of triples. And unless you have some sort of either a way of saying, we guarantee that in our triple store, if you find a first name, you will find a last name, or a stronger statement saying that if you want to enter a document about a person into our triple store, you have to have both a first name or a last name, or we won't let you put it in. If you don't do those things, you end up with this hyper defensive programming where anybody that accesses your triple store has to say, whenever I pull any triple, I have to say, what am I going to do if I don't find this? If I pull a record of a person and I want their last name, what am I going to do if there isn't a last name there? And as a programmer, I'll say, well, I'm just going to add a triple that says their last name is Smith. And somebody else is going to say, well, I'm going to add a triple that says their last name is Jones. And then you run our software together, pull the same records in, and they come out different. What you're doing is you're coding model logic in software's context. This is what you can expect to have there. Or as a machinable way of saying, does this collection of triples conform? It goes beyond that, by the way. It goes as far, conform triples represent a valid instance of a person, and so you can use it to filter collections of triples to find out where they go. The other thing is there's a specification called Scheck's map, which is sort of kind of an XSLT for RDF, which as you traverse a graph testing for conformance, you can make things happen. You can emit forms, you can emit documents, you can emit other RDF documents, HTML or RDF, and use the tags out of FHIR.ttl to annotate what you've got in a record is an interesting possibility. Another one is, I didn't touch on this, but in the FHIR specification actually says a FHIR record always has to have a human readable summary of what's in it. When you go out and look at the examples, there's always this section up front that's a bunch of HTML that shows you as a human being what's in it. One of the questions that arises is this is often automatically generated from the JSON or from the rest of the FHIR. The question is, where did this little bit of information in the human text come from? You could use the FHIR.ttl, the FHIR RDF, as annotations for that. Internet of Things, personal devices, where you want a very lightweight record, you can potentially use this as markup. Transforming other documents, markup on personal health records and what have you there, etc. And this is something we played with. It isn't running at the moment. We're going to get it back up. This is FHIR.ttl represented in the schema.org idiom. Now, how many people are familiar with schema.org? Okay, enough that I don't have to, I've got some slides on it if not, but this is the general idea, is that FHIR.schema.org has a bunch of markups so that you could take any document that's out there and you can say, okay, this, you could put a little RDFA around it that says this is the observation component code. You could start annotating documents to describe how they're transformed into FHIR records or what they mean in terms of what they're documenting in FHIR records. It should be noted there is a health.schema.org out there that's pretty active. That, I believe, is orthogonal to FHIR.schema.org. Health.schema.org is about the healthcare domain. It's tags that talk about patients and specimens and tests. FHIR.schema.org is tags that talk about records that have patient identifiers in them, records that identify tests, a subtle but important distinction there. Another thing that's interesting is there's a lot of secondary use going on in healthcare, I2B2 being one of several schemes for representing clinical data in a uniform fashion so that you can do statistic and all sorts of secondary analysis on it. I2B2 is great in that everybody can create their own model and run a set of tests and get results. It's terrible in that since you created your own model, you can't share it. They are working on a common ontology set of definitions for I2V2 called ACT. It's been several years in the making, and it's a big task, as HL7 has found out in the past 30 years. But it's also possible to just take the FHIR structure vocabulary directly and use it to model an I2B2 ontology and actually turn FHIR RDF directly into I2B2 content. So just an example here. Another interesting thing we've just been playing with a little bit, and there's a lot more to go on here, but using the structure, vocabulary, and reasoning, not a lot of time to go into it, but if you go out to this site, there's some examples here where we've taken the FHIR ontology and we've created some small OWL definitions of like this one is, okay, a final report that has a diagnosis of cancer. That's actually a fairly difficult thing to look for if you're looking at clinical records, because they're not going to say this is
Test, test, test. Det funkar.
Ska jag introducera dig? Eller stämmer det att du är Information Governance Manager?
Ja.
Vilken media?
Wikidata.
Wikidata.
Ja, en frivillig.
Wikidata. Ja, efterfrågan.
Och då är det
15 minuter. 5 minuter frågor. Så att för nästa talare, jag kommer också säga att för nästa talare så tar jag med mig headsetet här så kan vi ha smootha byten.
Ja,
Så om du lägger headsetet här borta sen när du är klar. Vad sa du? Jo, men 15. Ja, så är det 15 med. Ja, men det spiker ungefär 15 minuter. 5 minuter. Nej, den ska jag ha nu. Så ligger en där borta på nästa talare så vi får lite svung i det. So then I think we will start again. I hope you enjoyed the coffee and the sandwich and that will keep you up to speed until lunch. We now have about 90 minutes with different business cases. And for the speakers, I put a microphone over there. So for the next speaker, you could prepare by getting that while we have questions for the former speaker. And there will be speech about 15 minutes and then 5 minutes questions. So the first one to introduce is Christopher Wallström from Volvo Cars. You're working as Information Governance Manager, importance of metadata for autonomous car development. So please, the stage is yours.
Yep. Hello, everyone. I've took an interest in developing a method on how to find data, specific data in huge amounts of data. So yeah, Katarina already introduced me in a good way. And autonomous drive, it's a quote from Wired saying what it's all about, and the real job is essentially to improve the software that interprets the sensor data and uses it to reason about how to move through the world. But in order to do that, we need to have an idea of how to describe the world in a formal way, and that's been a bit difficult to find a good method for that. But first of all, in order to do this, to develop the correct algorithms to drive a car autonomously, we need data, and huge amounts of it, really huge amounts. It's loads and loads and loads of data. So the data collection is done through different sorts of sensors on the cars, and they drive around different parts of the world in order to collect the correct type of data. So we collect data from radars. We also have lidars on top of the cars in order to have some ground truth where we can have reference data. And we also have loads of cameras. And as you can imagine, streaming full HD camera data is loads and loads of data. It's so huge, it's hard to imagine how much data it is. And then we have these happy engineers that want to develop functions, and they need to find their way in all these data. They just want to find the correct data in order to do their analysis, in order to develop functions that actually drives the car in an autonomous way. So what we are looking at here is a method for finding data, and especially for autonomous drive. So the first thing that we need in order to do this is to tag the data in some good way. And we don't tag the data directly, but we tag the data in a data catalog. So the data catalog keeps track of where all the data is located and what type of data it is. We have different types of tags in this data catalog. So we have loads of administrative data. It says who generated the data, different dates on the data, where it was driven, what sensors was in the car, what was the weather. It's actually in a quite bad way since it's a web service and we look up the weather afterwards. But also what type of car and where were the sensors located in that car, and what was the setup of the car, what was the measurement between the axes, etc. Because all this information is very interesting for the engineers to do fault searches when they try to develop new functions. But the engineers also want to do loads of analysis on these types of data. So they write scripts in order to get more information out of the data. So for example, they can write a script to have more detailed weather. The simplest one I've seen is that they actually check if the wipers are going and how fast they are going. That gives you some idea what the weather was, but it might be a splash from a car or you just cleaning your windows, so you don't really know that, but it's some indication. They also want to find animals. They also want to know what the road profile is and the traffic situation. It's quite hard to describe this in forms of scripts when you look at camera data. It's not easy to have an understanding of how to describe this. So it's a quite iterative process. So you write a small script that sort of gets some of the details and you refine that script to give you more details, and you refine it and you refine it again in order to get the correct information that you need. But essentially what you actually want to find and or describe is different types of traffic scenarios. Traffic scenarios is essentially when something happens in traffic and how can you avoid certain situations or care for other situations. So in the new XC90 you have something called LP something, left turn protection, and it actually discovers if it comes a car that you don't see and it stops the car. So this is one scenario that we want to identify in order to create the algorithm that makes the car to do an emergency brake here. Yeah, it's a nice video here showing off what will actually happen. So essentially this is a scenario that we want to find, and if you want to find it from the real data, not from some simulated data, but you want to find it how it actually appears in real traffic. So in order to try to describe these different types of scenarios, we have different standards. There is one called open scenario. An open scenario actually is the exact descriptions of how cars are moving. So you can actually write the exact algorithm for how a car is driving or changing lanes or doing whatever. It builds some open drive and open CRG. That one is just how does an intersection look, and the other one is what is the road surface, because autonomous drives looks a lot at the road to see where the car is located on the road. But this is built from another purpose. So this is built essentially to create simulations of the different scenarios that can appear. But what we are trying to do is taking real data and match it with these types of scenarios. So this is just another type of scenario. It's a cut-in. It's the only one of the few ones that actually got the name, because all traffic scenarios that you do every day, they don't really have names. So we have to invent those names. It's no real name for what it's called when you enter a roundabout and exit it. It's you do it every day, but it doesn't have a name. So, but cut-in has a name. So this is just different types or describing the way a cut-in might appear and what can happen. Is it a collision that you need to avoid here? And it's extremely detailed. So you can see that you have the seconds, you have the different speeds, and you have the different speeds between your own car and the car in front of you, and what the lanes are looking like. And there is also another type of scenario standard. This is Pegasus. This is a German one. It has more details in it. The other one was just dynamic and static content, essentially, and how they relate to each other. But here you can actually see the street level. What is the pavement like? Is it tarmac, or is it gravel, or is it something else? What does the traffic infrastructure look like? Is it any hindrances in the way? And how do we take care of those? Temporal modifications. You can't actually trust the map data that you have in your car, because it might be updated, or there is just traffic work or whatever. So you need to take care of that. You can do that in several different ways. You can see that other cars has avoided that area for a while, or you can check traffic jams or whatever. But you need to take care of it. There are also all sorts of movable objects here. You have to identify what type of object it is, how fast it is going, and I guess how heavy it is as well. So for example, we look at animals, and for a Nordic context, a moose is very important to identify, and we can probably rule out camels and elephants, etc. But do we really need to know that it is a moose, or is it just enough that we need to know that it's a large animal? Because we can't keep track of all animals that can appear next to the road, because there are several animals. And also, of course, environmental conditions. Is it raining, snowing? What height does the sun have? Because that might influence the sensors. Is the sensor blocked in some way? And is it related to the environmental conditions? Sorry. So in order to try to describe all these different things, we need to look at linked data, and we also need to look at the definitions. So we have tried to find several different types of definitions. This is from OpenStreetMap. They have some definitions of the different types of roads, but there are so many different types of roads, and we don't really know to what amount of detail that we need to know, because everything can in some way influence how the car will behave or how the sensors will react. So we need to take care of that. But we need to combine all sorts of standards in order to find a way to describe our world around us. And it has not been done in a comprehensive way before. There are some initiatives. So Open Scenario is part of ASAM. That is a huge standard organization that takes care of these things. But they're usually from the ground up and not from the high level, so you can't really identify a traffic situation, but you can sort of describe what the traffic situation was like. We also look at different types of weather descriptions. The problem is probably not to say that it's raining, but to what extent is it raining, and what definition should we have for rain, because the definition of rain is apparently different across the globe. If it's raining heavy here, it's not the same as if it's raining heavy in, for example, Japan. It's different things. So we need to agree on a standard that says that this is the correct amount of raining. And there are loads and loads and loads of meteorological standards around the globe. Hopefully we can find a good standardized one. But what we do then is that we model each of these things inside a taxonomy tool. And the taxonomy tool also has support for ontologies. So we try to build a formalized ontology to describe all the different types of objects and things that can appear. So we have the dynamic objects, we have the static objects, and we have the environmental conditions. But we drive this sort of iteratively. So once the engineers request something, they can put in a tag into the system, and they can have a request to make it globally available for all the other engineers. But sometimes they just put tags on information in order to refine it themselves, because they have selected a certain amount of data and they want to refine it to do some analysis. But sometimes when they do something good, we want them to sort of put it into the systems so others can reuse it. And that's how we will build this. So we will have some formalized process and of approving and trying to find standards that match the things that they want to find. But we don't try to do it all in one way or all at once. We just try to catch whatever they want to find. Otherwise it will never stop. Describing the world in an ontology with everything included is probably not possible. So just to go back to a specific case of this is, if we have a segment of data, collected data, we say that it was a moose in this segment. There's also an intersection and it was raining. And what can we use this for then? We can do nice things like graph search. So you all sort of know what graph search is what you iteratively search for something. So you start with some parameter and then you refine it with other parameters. So essentially I just made an extremely simple example here. You have the intersection and you choose a certain animal that you want to find in this intersection. And you combine it with a weather condition, and then you get all the data that is tagged with this different situations. And that's it. Any questions?
Thank you, Christopher. Questions? Yes. In the back there, Eric.
Thank you for your good presentation. I'm from Gothenburg, city of Gothenburg. Will you change? Will you give up?
Contracts that sort of needs to be cleared out, but we can look into it, of course. Yeah.
Because we are not interested in the secrets that you have in your car, but for example, potholes. If the city doesn't look, the environment doesn't look the way we promised. That's the information. We want to make an efficient maintenance plans, for example, fixing the potholes that your cars will drive on.
We can, of course, discuss the standards that we used and how to sort of refine them in order for your usage.
So you will change, you will open up data for us?
There is actually some initiatives that looks into different types of conditions and how to report them back. But I can try to put you in contact with those people working with that.
Please do that, because that's important for giving good services to the people that are here in the room today.
Yep.
Thank you. Do we have another question? Yes.
Thank you for your presentation. You talked about ontology modeling. How do you model ontologies? Do you use some formal methods?
It's essentially RDF that we use for the modeling part, but we starting with building up all the taxonomies, and then we need to see how we unify them on a certain amount of data. So we haven't come that far with the ontology modeling itself, but we have it up and running. So we have it for weather and some simple things.
Did you consider using web ontology language, OWL? Did you evaluate whether it's suitable? What are the disadvantages?
We use a tool. I think it uses SCOS, and I think it's possible to translate it to OWL.
Thank you.
Thanks. Then we have one question over there and the last one over there.
Hi, do you have enough data to say whether the moose avoids the intersection in the rain or not?
It's essentially up to the engineers to find out, but I don't think so at the moment. It's very hard actually to get animal data because it's not a very common occurrence. So engineers are extremely interested because it's hard to find, so they want to find it, but I will try to give you an answer later on, or in a few years' time.
Thank you for the interesting presentation. I work with training at Semcon. To my understanding, you won't see a totally autonomous car before Christmas, right?
Probably not, no.
To your best of your knowledge. Do you think that you will have the data coming out of your research to have the car in order on its way to autonomous? Are you thinking of using the data to have the car learning the driver how to behave better than the driver does presently?
I think that's already built into the cars, right? In some way, it's very hard to change the lanes in the XC90, but of course that's one thing that I know that other researchers are looking into. For example, how you should be sitting in the car to be more safe.
Thank you.
So thanks a lot, Christopher. And the next speaker is Dr. Rajesh Sahay from AstraZeneca. Welcome. Yes, you have a microphone over there. And then you need a computer or? Oh. No, okay. Where is your presentation? Aha. Okay. Let's do it like this then. You take your own, okay? While Ratnet put his computer into place, I will present him. He is a lead and associated director of clinical data science at AstraZeneca, Cambridge, UK. He has over 15 years of research and industrial experience on data interoperability and analytics in several different areas. And today, Rajesh will tell us about the knowledge graphs challenge, a variety of data. So, can I help you? Yeah.
Which one?
You could connect with. Do you want that one or?
Yeah.
On that side? Yeah. These cables, one day.
Yeah. So the topic that I'm talking about, the knowledge graph, it is in a hype curve, but people like me, a person like me who coming from linked data and semantic web background from last 15 years, is not a surprise keyword. It's a continuation. So what a graph technology can do or cannot do, and given the lesson learned in almost a decade, what are the challenges ahead to realize a knowledge graph in enterprises? So that's the topic today. That what knowledge graph can do and what are the challenges are there. So pretty much currently I'm leading a team on clinical data science at AstraZeneca, and past several years of my experience, all in computer science. Coming from domain side, I worked several years on electronic health, on the clinical trial databases. Coming from health, 15 years of, and as well, I did my master's from KTH, so national travel. So in 2012, that was the time when knowledge graph came, and what you see on the left hand and what you see on the right hand. The right hand time, if you were to type Barack Obama in 2012 or some other person's name, it was basically a few Wikipedia description. But what is happening now? This snapshot is taken from yesterday, and what is happening now? That this is what you see, that Obama's Wikipedia details, what books he likes, his Twitter, Facebook or social media account, his Google search recommendation that okay, somebody has searched Obama, what other search people have made. And this right hand side is growing. And it's growing, and at the same time, this data set is not coming from one sources, they are coming from multiple sources. So how it all summary is coming into one place. So this is the magic that Google is doing, and there is a lot of hard work behind that. Especially I know because I come from the graph background, that what pain is there. Exactly same thing, because okay, that's fine. Google has done. They started from 2012. Now they are growing. Coming from AstraZeneca perspective, we also want to realize something like right hand side. So if I type a generic, so I should be able to see event beta log has. For example, rash, vomit, heart rate increasing. What are the biomarkers which are associated with that? Is there an association with some other disease? Maybe I'm taking beta log for my heart rate, but maybe some other disease can also affect. What are those associations are? What is the trade names in the market? And where it is prescribed, in what kind of a disease. So this is a summary of a beta log. Now in a drug making company, it's not only the drug, it's all about genetics, proteomics, clinical. So if I type anything like adverse event or a drug name or a gene or a name of a gene, I should be able to get this summary over there. And this is AstraZeneca has realized, and very recently there is a work and there is a dedicated team is working on to realize the right side of it. So the question mark is how to get that, and the big question mark. And as I said, that it looks simple, but there are multiple data sources behind that. Even in even to satisfy to get this query, even with just only in AstraZeneca, 50 plus databases may be there, and spread across US, India, Cambridge, across there. So imagine the scale at the worldwide. So what again for the same problem in 2016, MIT and one of the strategic consultancy company, they published a joint article that in big data the problem is not volume and some other V's. The real problem is variety, which is where huge investments of a companies are going, because they have going through XML. RDF is still not on the mainstream, but there are a series of different storage technologies and formats are there, and huge investments are there. So what is happening at the moment, not only a relational world now, what you see on the left hand side is the MySQL, GraphDB, MongoDB, CSV. So it's a mix of data formats, different data models, different storage engines. And typical step is in any enterprise, let's build a data warehouse, a common data warehouse. So what you do is that you do ETL, wrangling, curation, confirm, and then confirm and confirm. So what you do here is that you take the variety, you kill the variety, and you build one common model. It is fine for a controlled environment, but the problem now is that we are moving slowly from petascale to exascale, so exabytes, petabytes to exabytes. How much this could scale, this common one repository, one data one data lake, this approach won't scale. So that's the problem, that there is a bottleneck, there is a dead end ahead for the architectures that we are following in the enterprises. So the lesson learned in typical data warehousing approach is that there is a huge data conversion cost is there, ETL and all those stuff, wrangling, because you're taking from multiple sources and you're just making one big monster. There is a performance overload, and if the data conversion involved, if the significant is involved, then if you're converting an XML to RDBMS or a graph to RDBMS, how you will preserve the semantics, tracking updates, and so on. And the larger debate at the moment in the database community is that where we consolidate everything into one, or is it fragmented or federated approach will work. So that's the bigger large scale database debate is going on. And this is, here comes one of the Michael Stonebraker's work. Like I think we all know him. So back in 2015, and exactly that was the time, I was also leading a team that was developing a federation, database federation engine that was connecting data sets in three clinical U locations, one in Lausanne in Switzerland, and hospital, one in Greece and one in Cyprus. And they had clinical trial repositories across three of them, and it was trying to connect that in those repositories and answer questions like, give me all the patient who has these profiles, and queries sent, and you can get, or give me the association between patient having this profile and association of an adverse event, and it is going there doing analytics and bringing back. But we had our own architecture. I will come to the later what that architecture was that at the time. But exactly at this time, Michael Stonebraker has said in 2015, that was the time I think he got the Turing Award, and I think it was part of one of his speeches, that time has gone for the single model approach, and he coined the word polyestores. And through this because I was also involved into that, then I made connections with the team over there in MIT, and we had quite a useful stuff after that. So the long history in data federation is that, okay, you have I have so many data resources, do ATL, make RDB all of them, and do federation. So you are converting multiple to one single model. Same we did in RDF as well. So if you go through the background of linked open data and some other communities, there are different sources and all converted into RDF and provided through some Sparkle endpoints or some by other means. But realizing that one of the lesson learned in last decade is one of the huge challenge is to convert something to one format. So converting XML to RDF. So there is a huge investment. Why company will do that? We put so much of investment into converting into one particular model, and that was again and again this problem. And the problem is not this conversion, the problem is maintenance, the problem is and so many other practicalities. So I guess what we see from the polyester side, so the next generation could be to exploit the native data sources as much as possible. So you have a RDF, you have a RDB, you have a CSV, you have a JSON. Why not to exploit them directly? And to develop wrapper on top of that. So some sort of architectural that can exploit the native data sources and it still can answer your query will save millions and billions of money for the enterprises. And some of the key aspect will be to address multiple data model, not one but multiple, to accept the fact that we cannot kill the variety just by applying one. With this approach has never worked in the past. It will not work, because if there is one standard, if one healthcare standard can solve all the problem, why we have multiple healthcare standards? Why we have multiple W3C standards? Because we cannot simply say that that variety could be killed very simply. We have to adjust our architectural designs that can adapt and work on the variety. So architecture that can support multiple data model, architecture that can support multiple query languages and the translation between them, location, mapping, access policies, protocols. So these architectures are based, and it's not rocket science. People are working on that towards to realize this kind of a vision. So one of the work that I was, before coming to AstraZeneca in my previous job, we developed one of the federation engine, especially in the genomics area, which takes from large scale repositories like Cosmic, TCGA, CNV, all in different formats, and does query federation on that. It's still a prototype, but very effective, and I see lot of use within AstraZeneca for this. We also developed a paper jointly with MIT on that. And this was just published this January. So there is a whole architectural thinking behind that how this system would look like. And jointly with Michael Stonebraker's team over there, we also put a workshop especially on this topic at VLDB. So there is, and this is the third workshop this year. This will be there, and the whole team is coming from industry and academia to share their thinking behind that, how to combine multiple data sources to be used in enterprises. It's a good venue if you like that. So the challenge ahead is that, the good news is that multiple data sources like CosmoDB, Virtuoso, Oracle database, especially 18C, they have not started supporting multi-data model support. So you can store into graph or different, and you can still query. So this is the good news, that
you can use this in the last minute.
Thank you. Yeah, just to finish up, so the good news is that the database technology has already realized that, and why not, if the Michael Stonebraker is telling. But the four challenges is that to have an architectural thinking in enterprises, because we have to come from that mindset, let's build a data warehouse. So we have to come from that mindset, that how we can exploit our own existing resources rather than building layers and replicating. It's a very natural thing that your one data in enterprise is replicating several places the same data, because it is in several data warehouses everywhere. So that's coming out from that mindset. From the technical perspective, query will be realized, and so there is a whole bunch of work. So this will down to multiple PhD theses. And related to that is the data aggregation, because your databases are different. If you're getting result from them, how you will aggregate and have those kind of a view. And still, like how you will preserve semantics, because a graph, a table, a tree, a so there are the different semantics behind those databases. How you will combine them, but at the same time, this is not a rocket science still, because we have so much of learning experience in the linked data community about the semantics and how to preserve a semantics, and there are a set of works already done. There are several venues like RDB to RDF, D2R, XSparkle, SQL Spark. So there's a hell lot of work already there. So the problem is not the know-how, problem is the intention now. And so this is a typical cartoon that tells the typical scenario in a company, that everybody wants that single view, like a knowledge graph view, and data is spread everywhere. What to do then? And so this, irrespective of whether it's AstraZeneca or Volvo or some other company, the scenario is this: that you have a multiple data sources. How you will have a single view. And we have in AstraZeneca we already started on this. Let's see how it goes. Thank you.
Big applause. Thank you, Rajnan. Really interesting, and this is also my everyday life when the customer wants to see it in their way. That's tough. We have a lot of questions here. Eric, are you moving around the mic? Good, thank you.
So Sebastian Gable, Semantic Web Company, thanks for your excellent presentation. You've been talking about federated query models. What is your experience? Does a completely federated, maybe virtualized approach of the knowledge graph work, or do you need any kind of index layer, a central index layer, however thin it may be?
Yeah, so one of the work that I have shown you on the publications, and there is also a open source software that called Polyweb that we have developed in my previous job. It's the open source because that's why still I'm connected to that. Yeah, so to answer your question, yes, we have built a kind of a hybrid index model where you can have definition of graph but CSV file, but also where the relational databases is that, and that's the key there. So there is a whole. It depends quite a lot on how you design the indexing mechanism, but this is possible. Yeah, we are doing that. Yeah.
Hi, that was very nice. Chris Southam from TW2 Informatics. A pragmatic question: What do AstraZeneca or any company do if those drug name searches produce misleading or wrong information, either on the left or right hand side?
So it goes back to the questions of how, from the very initially, databases has been designed for the query and search. If you take 10 years back, the original intention of databases was just to solve one business problem and not to have an enterprise-wide Google-like search, and that's why this problem is coming. And this is the gap, not in AstraZeneca but other companies as well. This is the gap that if you want to have an enterprise-wide search and a knowledge graph, then a new way of thinking is required, a new investment is required. And we already have. I mean, we have already started this conversation and this beginning towards in AstraZeneca. That's all I can say. Yeah.
Thanks a lot for your presentation. It's a very interesting view. I wanted to ask you, do you think that querying first architecture view is the right one? Because modern enterprises, they moved to the microservice architecture. And the idea of enterprise software architecture is that you never let any application outside of your boundary to access your data store. Yep. All the access should be through the API.
Yep. So yeah.
So have you been exploring bidirectional? Because querying approaches, they're mostly, especially if you use technologies like RML, R2 RML, they're read-only based. And it's really tricky to have write back, especially if you have a lot of business logic. Have you explored similar architectures, poly database based, but through the API level?
Yep. So I think there's a multiple questions here. So but the good one. One thing is privacy. So privacy is something that once you have a search technology, what you can search or what you cannot search or what you can get from is the privacy questions. So in order to drive a car, you first need a car, right? So the car, to have a car, so have that architectural thinking first. Yes, these are read only, as you said, R2ML, because their work is going on to have a transactional RDF stores as well, where you can do that. It's upon your use case. Whether, as I said, in the polyester community, that the workshop that is there is already work started on that direction to not only search but also on transaction side. So there is a huge work already there. Yeah.
Thank you.
Yep.
Do we have another question? Okay, thanks a lot,
Thank you.
Ratnesh.
Thank you. Bye-bye.
Then our next speaker is Ante Barik from Göteborg Stad, who works with digitalization of the city of Gothenburg. And Ante, you will tell us about smart cities through open and linked data. I will help you to. Yeah, it's just to push that one. That's no.
Huh? Okay.
And then you find that one. Yeah. Okay. Good.
Wonder how much time it takes for the whole world to conduct these things each day.
Too much time.
Think so?
Well, we have the time, so take your time.
Couple of minutes each meeting. Okay, welcome to the city of Gothenburg. All of you, guests and also citizens. I'll try to give you a short brief. I'm gonna do the little bit about the corporate bullshit sites, but you know, it's a part of the job. Good one. This is our official presentation. It's in film. I won't show the film today, but the thing is that we are doing big challenges in the city. We are growing rapidly. We're growing to roughly with 90,000 flats in the central areas. So we're building everywhere. Behind you, we are building one of the European largest buildings, be close to 300 meters. And so we're facing big challenges in the infrastructure, in the roads, and also electrifying the city. So this is a little bit in the figures. Close to 560,000 inhabitants. We have 10 districts, city districts, and also we are organized within 20 committees. We have also subsidiaries to the city that owns 72,000 flats. Nobody here in this room had been able to come here without using our services. Thing is, the system have the electricity, the public transportations. Everybody has used something of those to coming to here today, and we're responsible for everything of those things. We take care about people from the day they are born to the day they die. That's the complex situations. Every time you can see what we are doing is to provide services. Services for a child, for transportation is one thing, and for a managing director is another thing. So this is in the figures, 1.75 million in the Gothenburg region that we consider as a region, where our healthcare system is provided to our colleagues, and also the labor market. It's commuting people 1 hour round of Gothenburg. So for example, you who are familiar with it's Falkenberg, for example, is the labor market. So a lot of people commuting into the city too. We are 55,000 employees within the city. It's the 4th largest employer in Sweden. So it's a huge organization. You can consider it as a big heavy boat, or a lot of small boats going the same direction. And that's the thing is for me and for my colleagues to get the ship into this digitalization that we work with to go in the same direction, to provide the services for those who we are for. Our lead thing is we are a sustainable city. This is not our city. This is our children's city, because we have just lended it for our children, because we need to leave it back to our children in a better way than we received it from our parents. So we have a big responsibility. It's ecological sustainability, economical, but also social things, because we have just lended it from our children. Okay? How is the tax used? We are turning around in the city 52 billions. Among 34 billions are what the taxes goes to. We have services on the Gothenburg.se that you can put in your that are employed. You can put your monthly wage, and you get exactly what goes to what, because we are an open city, open to the world. The thing is, here we have a big challenge in the elderly environment. It's sorry for being partly in Swedish, but I didn't have the time to change this for today. The thing is that 90% of all our taxes goes to school and the elderly environment, our healthcare system. And people above 85 years, we will increase roughly somewhere between 40 and 50% the upcoming 10 years. So we will have in Sweden in total 2 million people that are some kind in need of those services that we provide that we didn't have before. So we are lagging. We have a big challenge in 5 billion budget cutting, and that makes us forced to use our city smarter, our tax income in a smarter way, because we cannot increase the taxes because we are already on a high level. So that's a big challenge, and then we need to work smarter with all those resources that we have. Even we have the problem also that we are lagging behind with the care sisters, for example. Care sisters, yes, caretake. We are lagging roughly in Swedish on a national level with 560,000 working in the healthcare system. That's as many as the population of Gothenburg. That's not possible. We don't have the people. This gives you a brief where we are in the digitalization of the society that the EU does. And we look quite good in the connected way, how we are using internet services, how we are using digital technology, and we are on the top level on the European level. If we are looking in how we use e-government services in 2016, we're also on a high level. And that gives us, the thing is, we pay a lot of tax in Sweden. And people are very nice, they love paying tax because it's quite simple. So that's a typical one service that we use a lot. But if we look in how we share data within Sweden, then we are lagging far behind. We are not changing data between our silos, within our organizations, and the people are using services between our organizations. And to be able to compete with those other countries, we need to exchange data in a controlled way. That's why that's the key thing of providing services, is when you combine and link data to each other. And these are sorry, this is also in Swedish, but 1 of 4 are considering that we are looking up to their expectations of services. So they are not happy in our city. And so we need to wrap up and do provide services much better, because the citizens' expectations are much higher. This is a picture that we are stunned ourselves. This was in the future of that we were considered smart cities. Gothenburg is number 2 in the world, and we are looking in with how could that happen? But when we looked into the criteria, it was 16 criteria. There were open Wi-Fi, we have it. Public transportation, electricity. We have the self-driving shuttle, we could see the other side. We're doing a lot of things. And all those things together makes this city much more efficient. People like to be in our city. And that's our main goal, to make people to want to stay in our city. So obviously we're doing something right, because we're up on this map. So it's a lot of initiatives that are doing locally in our, because we have the silos within the committees too. But we are doing services now, and we are starting to combine data and informations and sharing data. So it's about simplify, make more efficient, and also open up the city. So we share data. Where Volvo? Where are you? Okay. This is example of my city, min stad, that you can make a dialogue. You can see, I like this spot, I want a bench here. You can make that as a proposal, and we do take that data, but we do it in a manual way today. Okay, people want a bench here, well, let's fix it. We don't make it, when the guys that put out the benches, okay, today they want a bench on this spot. That doesn't happen yet, but we are going to that part, because we are collecting a lot of data. What do the citizens want? Because those are the ones that we are for. This is called the Gothenburg proposal. that gives if you were given a proposal and that gets digitally 200 votes, the city steering the committee need to take that up on the board. The people want the change, and that's the thing that we are looking into. So this is direct democracy used with the digital services. How about our open data? We are, I think, Kim, we have 40 data sets or something that we are providing increasingly, and some of those are quite boring. It's Colada, it's more static data, but the thing is that the most interest voices. We put everything that we buy, we provide the invoices publicly shared. So if people want, what are you doing with my money? Please, we'll go inside. Is there some corruption? Go inside. You look at yourself. So when we started this up, maybe something wrong. Somebody put on the wrong account. Very good. We have 560,000 citizens that will correct it for us. What's the problem? Open world. And then I have an example of how we are starting to work with the data and how we will try to do this more smarter way. So we looked in this Boyd Cohen Smart City Wheel, and we are talking about smart mobility, smart environment, smart government, smart people, and those things are that we use in the data, and how to make the human perspective, because as I told you previously, for example, the health system, we have the gentleman here talking about FHIR. We have 2,000 beds in our hospital, Solbrig sjukhuset here. It's the hospital, 2,000 beds, but we have 6,000 or 7,000 beds at home, taking care of people. We want to exchange medical. If it's a call, for example, a patient that has call. It's called a call in English too. Yes, you want to wait them because they have water in their lungs. You need to move them to a hospital or come home to us to wait them. But why don't you step on the wait and say okay, and you can detect it. So we have a lot of things that we can do in the healthcare system, in the traffic system, and also we are changing because we are swapping these cars, self-driving cars. How should our society look like? Do we need parking spots in the center of the city? Would we need that in the future? With roads need to be that wide? Things that we need to consider today. How is the charging infrastructure for all those electrical things that we are doing now? This IRIS project, I won't bore you with that one, but we are recycling the batteries from the buses that Volvo has been supplying with between the Chalmers areas here, and use the batteries because they're not good enough not strong enough for running out of the bus, but it's good enough to keep a thing in a public house. So we're making an electrical district where the electric self-driving cars are not just consumers, they're also contributors at one areas when people start their cooking in the morning or the coffee in the morning. So a Tesla that's been charged over the night when the peak was low, and then when the peak comes, is also a provider of electricity. So those smart grids, we have already done those things. So we need to think smarter. So we have looked into the things, the focus areas that we are looking in. We are talking about culture and leisure, democracy and engagement, education, healthcare and safety, business and labor, and also city development environment. How should we build this new city, because we are building so much, and making a digital twin of the city. And that's the thing that our building departments are looking into. We are aiming to have that finalized in 2021 when our city turns 400 years. And why should we have a digital twin? It's much easier to test things in a digital twin. You see, the car industry doesn't give us a car and it crashes. But the thing is, what we sometimes when we build a bridge, we're not quite sure how it will be used, because when we start to build the bridge, something can happen until that. What does happen if we increase the amount of flats? I think they are building, close to 300 meters. What if we increase it to 400 meters? Yesterday it was a fire in Falkenberg. It was a house that had flats i lägenhet. Stores. It was 14 stores. But the fire stations just close to the 7th floor, 7th store. So those things that we need to consider. And how much should the water pressure be up to put up to the sprinkler system if it's 400 meters? Those things we can test. And now, finally, I won't bore you more. This is our main thing, and thing is we want to the digital customer experience must be simple, open, and efficient. Make it the preferred choice, because we cannot be able to do everything physically. We need to do things that the machines can do in that way. We cannot do it with the labor or man's hand. So we need to this challenge with the older departments, the people that get older. So this is the way we are building our model. We need to have a city information model, how we exchange between our committees. For example, in the healthcare system, what does happen if we outside when we move people from the hospital to the home? What does happen in the transportation? What's the mobility? Electrical metering. As of today, we measure the electrical meters standard each second. And that's to produce an invoice the end of the month. But information from the electric meter, if my mother has used electricity today, is quite interesting in the other part of the system, in the ecosystem. Is she alive? Has she been using water consumption? That's why we need a city information model where we can use informations in other ways to be the preferred choice to make our service much better. It's not about the invoice 30 days later. She might be dead. Okay? So we need to cooperate much better. We need to have the basic infrastructure on the way. We're talking about fiber. We are having close to, I saw our authorities, Post och Telestyrelsen, that looks into how much the fiber connectivity. 98.5% of Gothenburg's households are having 1,000 megabit or 1 gigabit in their wall socket. And that's availability, and that's a big thing that we can do. So if we have 1,000 megabits or 1 gigabit in the wall socket, it's not that difficult to put up a camera or doing some kind of surgery, or not surgery, but exam of the person being at home. We cannot move people. Let's come to people and do the things. That's where we get efficient and good services. So this is what we are aiming for, the digital twin, and also how we will steer it. Because on top, difficulties is today when we are having a steering model, when the cost comes from one place and the gains or the wins comes from other parts. We need to steer the city in a smarter way too, because we need a modern way to steer the cities as well. So that was all for me from the city of Gothenburg.
Thank you. Thanks a lot, Ante. I learned quite a lot about my home city, and I'm happy that you continue to develop it. What kind of questions do we have for Ante? Any questions? Yes. We start over there.
Okay, it's on. Hey, hello. So when you compare Gothenburg with different cities, like say when I personally travel to German city like Munich, Berlin, then say even Frankfurt, you have like instruction that are given in multiple languages, like say German and English. Why isn't two language instruction being followed in Swedish city? Like if you travel in buses, all the instructions are only in Swedish. Why isn't there any instruction given in English?
Oh,
I mean, when you have to be open to the world, I mean, you need to incorporate English as an international language as well. So it's, whenever my friend travels with me, I had to translate what the driver is telling me, the announcements on the screen to him, and then how do you, I mean, sorry.
I don't have to consider if we should make this an English country or not, or which country, because it's not the largest. Obviously, English is one of the largest languages within Europe, but Maybe we should put it in Spanish because it's increasing or having the science. How they are oncoming and publishing do in Gothenburg. But there's a widespread how far the municipality has done. And that's a good thing because Sweden is controlled, decentralized with the municipalities. So we have increased democracy, what we do within the municipality. That's also a problem when you do centralized good things as on a national level, because we said, well, why should we do that in Gothenburg or something? So, for example, Denmark was the first. They are strongly centralized when they govern the country. So the problem is how we're governing in Sweden on a national level. That's why there's a bit widespread. Yeah, I think we should need some of North Korea. We will have the good steering, but we don't like that thing either.
Do we have any more questions? Okay, then thanks a lot, Tante.
Thank you.
Our last business case before lunch will be presented by Professor Mark von Rosing. Mark has dedicated his research efforts in patternicity and has identified repeatable patterns of outperformers and underperformers for over the 25 years. Mark will introduce us to strategy ontology. So please, Mark, when you feel ready.
All right, can everybody hear me? All right, challenges out there of the market that you actually want to answer in introducing an AI ontology. So that's going to be an extremely difficult. Good news is there's 2-hour session tomorrow on the architecture of the concept. So let me go here. And the reasons we call it a sustainable AI ontology is because it is called from an academic world, or for those of you who work a little bit with ontology will know, we will be discussing it on class. I will show instance type levels examples, but it's in order to make it applicable for general usage. So, all right. Well, there's no question. Every one of us knows that the ability of existing AI and knowledge graph concepts to analyze, design, and execute the concepts within organizations is actually alarmingly poor. Has a very bad track record. We know it is emerging, it is growing, but it is alarmingly poor and it hurts. So bad that, as a matter of fact, this is conventional digital transformation, which, by the way, the time fails. But still, 68% settle for dilution for value of really, really low performance. 20% actually live with the fact that they receive less than 50% of the hoped value or planned value. And 12% say, well, we believe we received them or we got more. In artificial intelligence and knowledge graphs, this is actually worse. Which that really should alarm one of saying, whoa. One could be discussing, well, there's reasons for that. The complexity, the difficulty, the aspects that the data is in many silos, etc., etc., etc. I know you know that, which is the reasons we are here. So, therefore, based on a long-standing semiotics and ontology research work done by the Global University Alliance and its members, by the way, we are non-profit organizations. This is just a collaboration of universities together with different professors doing research and work. So what I'm presenting I am not selling you anything. I have no economic interest or wish behind anything. It is just for the pure fact of sharing and developing things. So this is some of the core artificial intelligence research involved. So we have Dr. Simon Pulvina, he's from the UK, Sheffield Hallam University. He's leading a big center there on enterprise artificial intelligence semantics. Then enterprise ontology is led by Professor Dr. Wim Lauria in Belgium. Then the most common AI strategies used is Jamie Kane. He's doing his PhD just based on that. Then comparing AI and knowledge graph concepts, what exists, which approaches are there. Then AI and KG modeling concepts, that's done by Professor Dr. Hans-Jürgen Scherun, which is in Germany. Then we have what kind of life cycle phases exist, etc., etc. You can read it yourself. I don't have time to go through it too lately. And I'm the one here at the bottom. So that's the core research team, done with a lot of different standard bodies involved. Myself, actually, I'm a chairman at OMG. OMG was mentioned a couple times. I also literally am involved with ISO development standards and IEEE standards. So here you see some standard bodies involved in this work. This is myself. I don't really have the time to go much through it, but I do pattern research, which is patternicity from the science. And I'm involved in developing 150 different standards. I'm in the World Wide Web Consortium, in ISO Consortium, the CEN, the European standards. Then NATO standards, I have a 5-year contract to develop standards with them. Then, and this is just my personal works. Then energetics, which is the oil and gas standards, then the Information Security Forum, and I'm a chairman in the Object Management Group. Most of you then know SAP. I literally developed SAP's implementation method, ASAP, and SAP's official implementation book, which is published by SAP Press, I've actually also written, which is still the one used. So, that was a little bit about myself. So what is it I do? I try to look at patterns of things and see how can you emerge and do generic things based on this. And some of you actually here in the room, I've even worked with. Don't we know each other? Wasn't it the European Union information for the air traffic systems? Yes, the air traffic management. You see, small world where you meet, where you have worked, which led to a carbon footprint reduction, and that was about exactly this subject as well. It wasn't tagged artificial intelligence and knowledge graphs. But that's exactly what it was in all European countries. So, first, a very short introduction. We see a major change based on the real physical world. Why? Because we are seeing a digital world emerging and developing, supported by a virtual cyber world that is there. Now, what is happening? This is about the Internet of Things, the society, the knowledge and the integrations. That's what this is about. While it's tagged different words, we hear about the Internet of Things, we hear about the data revolutions, we hear about big data, and we hear about the industrial revolutions. It's all about knowledge and information integration. So the social world is triggered by initiatives across multiple industries. Look at it. We have the smart industries, we have the smart cities. We literally just heard about the smart cities. Connected communities, lighting, water, management, monitoring, security, traffic controls. I'm involved in several projects of this myself. Then smart transport, smart economies, smart consumers, smart living, smart health. Very interesting, but you won't see that up there because there's a lot of projects that are also going on in stealth mode. I was involved trying to do smart border control systems for the US government and the Canadian government. After that project, which took 9 months, I went home, I deleted my Facebook account, deleted everything that I had on the internet, and have only professional pictures on there from, and I'm not joking you on that matter. If you come to the border service agencies, the reasons you give 24 hours beforehand your information, your address, before you fly, is because they will not Google your name. They have access to the internet service providers due to the terrorist data law. They will look at your address, whatever has been written on it, which computers have accessed it, and which other computers are there. That's why they need 24 hours to do that. When you come, they keep on looking at the monitor on the right, in the meantime on the border. They also have voice recognition. They literally say if you lie or you're nervous. This is not some futuristic way of looking at it. I know you need to give fingerprints and facial photo. You also realize that in the most airports you're going through, before you come to the baggage, you go through these glass doors that are like about 1 to 2 meters long. And then you see there's cameras up there. They record your movements. 20% is all they need to recognize it's you. Of your moves, of your face, of your nose. Yes, we are entered this world. And this is not, oh, whoa, this is not true. This is 100% true. All industries are triggered by what we are just discussing. As a matter of fact, some of the analysis that started all of this was, does your organization consider data intelligence, information architecture, artificial intelligence, and knowledge graph initiatives in your organization? Already right now, 45% say in electronics, aerospace. There's a huge amount that are saying we are moving in this space. This is not only that we can discuss, it's emerging. It is already there. It's just emerging technologies because they lag behind. But we will discuss that in a second. Look at what they are planning in the next 5 years. This will be booming 100-fold. Very interesting, we see new business models based on information models in the digital economy. I know we know this, but nonetheless, we actually don't connect that they are using what we are talking about. The world's largest taxi company owns no vehicles. It's all about information architecture and knowledge integration. The largest phone company owns no telco infrastructure. The most popular media owner creates no content. The world's most valuable retailer has no inventory, etc., etc., etc. I mean, the list could be so long, we cannot go through this. But we actually see new business models, never studied, doesn't exist, created on what we are just discussing. So, in trade, as a matter of fact, Financial Times, I just did an article on it that Financial Times published for the banker, which is the change of the business model of trade, how it's fundamentally changing. We saw direct trade before, then linked trade, then trading partners, then digital connected, then digitally integrated. Now we see they are going towards an integrated, collaborative model, which actually is changing the operating model. This is historically evolution of the operating model. This is now the existing operating model. This is what is emerging. I mean, which is then obviously that they are starting to do blockchain and multiple other things. Why? Because if they need intelligent collaboration, that is what we need to be doing. It's a means by which these trade changes are happening. If you look at it from a value chain, this was the enterprise value chain, by the way, described by Porter. You know, historically all that we lived in. This is the linked value chain. I am not joking you. Even in academia where I come from, there exists no concepts, no method to just capture this. And we are already here. This is not only about partnering. And by the way, if you look at McKinsey's latest study who says what are the most common strategies of organizations, it's about acquisitions. It's about partnering impact. So what I know you know what I'm talking about, but it's the aspects of how all of this is coming together to this is what we are talking later. But this is now emerging that we are talking about information architecture. Suddenly we know it doesn't matter what we are doing, it doesn't matter which technology we are implementing. If I don't solve this good, I can have whatever I want, that's where I will fail. It will become the weakest link in the chain. So, we also see this is triggered by the very industries of the benefits. The new business model is based on AI, meaning artificial intelligence, information architecture, and the knowledge graphs, putting customers in the center of the value chain. This is the percentage of respondents citing significant or high levels of value chain collaboration as a result of their initiatives that they implemented. This now you see by different industries. And we heard it here today. This is nothing else. This is just some of the data and the facts. So, in summary, before I'm moving on to the core of the things that I wanted to say, a new innovation potential is actually coming. So compared to the previous multiple digital innovation concepts we have heard about, artificial intelligence and knowledge graphs innovation can disrupt almost every industry in every country. Wow! So that means in breadth and depth of the changes of entire transformation of entire systems, production, management, governance, the way you interact. The possibility of billions of people connected by mobile devices with unprecedented processing power, storage capacities, etc., etc., etc. So, why is this so important? If you look at linear business innovation, I'm talking business now, companies, organizations, their innovation. I do realize that these are more like this. But the point is that basic principle, growth stabilizes and the next innovation starts. Stabilizes or it goes down, next starts. But if you then would take it through, you have a linear business innovation of a growth. The challenge we had in the past with artificial intelligence and knowledge graphs and information architecture is the technology lacks the status quo of the potential of what could be done. What is changing this whole thing right now is, oops, we have an exponential business innovation potential. Why? Based on the AI, knowledge graphs, and information architecture concepts. Therefore, with this new technology, we have new potentials. We already see right now the predictions are, and this is for the last 5 years that has happened, ever reached the top. Top 500 organizations, they have the brand, they have the market, they have the money, they have the customers, right? And they have the product. You were about 50 years up there. In the last 5 years, OECD has come out and said it has changed. If you ever do reach the top, you are the maximum of 15 years up there. Why? Because the market is changing. Somebody else satisfies the need faster, easier. So we see so much potential, which means that organizations need to adapt to it. The times where incremental change, continuous improvement, and I have nothing against that. As a matter of fact, if you actually Google my name, you will see I wrote for Elsevier the 3 series called The Business Process Handbook. So I have nothing bad to say about business process management or process engineering or lean or process work. But you can no more do that with this. You can no more apply continuous improvement out of the need for change. We are talking a total innovation concept is needed. And let's face it, you do realize that the most architects we talk with, they don't even know the difference between transformation and innovation. They don't know the one is based on existing things, where I optimize, I improve, and the other is innovate, meaning doing new. Believe it or not, most even don't know that basic concept. They use this interchangeable. So, this is triggered by the things that we are seeing. The speed of change is triggered by all of this. Digital manufacturing, machines to human, digital economics, social communities, bioinformatics, neurotechs, nanotechnologies, cybersecurities, etc., etc. Try to summarize up here, which is doing an interlink of things. which is again is triggering one industry, which is triggering another industry, which is collecting to another. Obviously. And I'm so sorry that I had to show it in graphs. How in the world do you summarize that we are in a total changing world? So, we put here a trend curve together of an AI trend curve. Why? Because we already discussed, somebody even said, oh, well, it doesn't exist on a trend curve. Well, we actually put a trend curve together. We are seeing here the early adopters. This is with the pilots. We're already doing smart dust, digital security, people literal technology, personifications, smart robotics, all of this. Brain-controlled computers. Then we have the phase where there's initial rollouts. Here you see. This is where you start having it starts to be an acceptance. Question of Vilo and private is actually here. Then inflection of attitude. Then you have the where you start to have a performance curve. Now, one could argue, and for those organizations who say this is historically, in IT, in information technology and information architecture, it was the idea. You adapt from here on down. Why does this not work in this one? Because you did it to disrupt. Anybody remembers at the past 10, 15 years, not the past 2, 3 years, we don't hear that anymore, happily. All these consulting companies, they said best practice gives you a competitive advantage. Heard this before? This is the most, excuse my French. And by the way, I would love if you move to France. Give that feedback to France. Every sign is in France. And every person you ask for direction answers in French, even though you spoke to them in Danish. In English, but if I thought you give the feedback here in Sweden where everybody speaks English, I mean, try to move to France and give that feedback. They would already be mad at you already at that question. Anyway, but the whole point is, this whole best practice thing that they are talking about, it doesn't work here. Why? Because first of all, best practice can't give you a bullshit. Best practice can't give you a competitive advantage, because if it's already best practice, everybody is doing it. How in the world can you get any better doing when everybody's doing the same? I mean, that's the most nonsense argument ever made by consultants. Leave that bullshit. So, but because they really need, this is about disruption, right? So if I'm adapting here, I'm not disrupting as much. As later I adapt it, as lesser I'm disrupting. Now comes the beauty of the knowledge graphs. It can add to you personally value because you can put it differently together. What a company did in this way does not mean that it's exactly the same for you. Therefore, actually, here's a wide range of success initiatives at this level. And this is where you start to have a full adoption curve, where it's a standard adoption of it. Which, by the way, you would typically start to see that they need to do life cycle management. Because now it becomes so complex that it's not point-to-point initiatives. No single project governance or AI governance can be handling it. It becomes so complex. So, that was the short version of this. The key barriers of exploring, then we come to the ontology. The key barriers of exploring this whole thing, which led us actually to develop, because in the start all we wanted to do is to kind of capture the trends. What is happening? What's hot? Why are they doing it? You know, that's the normal thing that you actually do from an academic perspective and from a standard organization perspective, which I work a lot. Well, in this case, it came, what are the greatest barriers inhibiting the organization from exploring AI and knowledge graphs potential? Lack of AI concepts to enable technology interaction. So, whoa! So they buy the technology, but they actually don't have a lack of concepts of how to use them, very interestingly. Uncertain ROI, meaning an insufficient business case. I'm talking here value case potential. Most they don't understand and document the drivers. Implementation in silo, lack of change related to new AI solution, meaning that versus the old world, that's actually really, really poor. Now here we're talking about, that's really, I mean, whoever bought those consultants, they should be banned and never be asked to come to back if that is done. I mean, here we're talking just poor project management, portfolio management skills. Then poor tagging mechanisms, absence of capturing the value drivers, no connectivity between business and technology, and lack of skilled works. Please note, these are about semantics. This is about knowledge and skills. Believe it or not, most architects that I meet, and I meet quite a bit, they don't even know the difference between categorization and classification. I'm not joking you on that matter. Do you know that this is the basic, most fundamental thing you need to know in order to do this, what we are talking about? They don't know that categorization is putting things into groups and classifications is to assemble it by order. A, B, C, 1, 2, 3. That's why they're discussing so much around on FHIR. It gives so much value because somebody finally does the work for them. That's what it does. Plus a lot of other things, as I also work with it and value it. So, now let's go into the ontology. I am starting with architecture, meaning the technology architecture. Then I take the value architecture, the capability architecture, and then I first come to the information architecture, and I do that on purpose. Why? Because every one of us is so focused on the information architecture that we don't consider the rest of the layers. And that's where the value comes out. So, started by the technology architecture, where we saw most of the things being triggered. It's triggered by the technology nerds. Some experts saying we can be using that. Here example, mobile device, computing, robotics. Oh, we can use smartphones, we can use tablets, we can use the Chrome, we can use iOS, we can use 3D printing. Here more 3D printing. Here more 3D printing. Here even more. We can use smart sensors, we can use augmented realities, we can vary about intelligence sensors, artificial intelligence apps that we can be also using to 4D printing things and generations. But what is the things they actually forget? This is what makes this work. This is the semantics of that very platform device. Why? Because my platform device is hosted by the application task. And it actually hosts my data service. But it's constrained by my platform rule, etc., etc., etc. We don't have all of this. Believe it or not, we saw that this is a #1 mistake by organizations. They don't have the semantics in place. And by the way, it's actually incredible that you have enterprises all inventing this very thing. Everything that I will show, we have done this semantic study. We've identified over 10,000 semantic relationships that are patterns within them that are reusable, that always apply. I don't believe you can find one case where it wouldn't apply. And we applied this for healthcare, all kind of entire Northern Health, 27 hospitals. We applied this as a pilot project to see if it worked out. Anyway, so all of the other things I will be presenting, they also have the semantics, but we don't have the time. So, then platform devices with their things. The platform components where you start to touch cognitive computing, man-machine hybrids, hybrid infrastructure, the robotics, the smart platforms. Then we have the infrastructure component. This is where we also talk about smart cars. Cloud robotics, cloud computing, quantum computing, ambition intelligence, LED lightning, etc., etc. So the list could be so long. This is trying to make it representative to get the idea. Could also be the cyber physical systems, the human robotic collaborations, or the smart homes. They all follow the same semantics within it. Why? Because they are infrastructure components, but they relate to different things. Then you have infrastructure services, you have infrastructure devices. Then I'm going to jump. There's no questions. We have the questions later, and I need to finish up in a few minutes. We're jumping actually over to what we call the value architecture, meaning the modeling. And they have the lack, which is actually immensely, it's incredible. Do you know that most architects don't talk about value architecture? They talk about process architecture. They talk about capability architecture. They talk about data architecture. They talk about physical things. What about the value architecture, where I relate my forces, my drivers, my strategy, my objectives, my security components, my rules, anything that gives direction? That's a value architecture. Look at there. The lack of drivers. You remember that was the biggest mistake that was there? This is just representative. Asset utilization, labor, inventory, supply, demand, time to market. As a matter of fact, after mapping this and our list became so long of the drivers, happily enough, we identified a pattern. There you go. Most common AI drivers. I'm happy to send anybody who wants the model, you can send me an email. I'm happy to send you the original graphs of this, in the case you want to use it. Then we have the value proposition. So they actually need to redefine the value proposition. Why? Because this is about customers, this is about centricity, this is about new users, input-output models. So if I'm not defining that this new technology has a new value proposition, how in the world can I do something? These are the most common 3. We identified other 17, but these are the most common 3 that could be used. So, same thing for risk. These are the most common risks with knowledge graphs and AI. The list is longer. I'm happy to send it. Anybody of you who says I would like. And by the way, any academics here, you can contact me. I would love to collaborate. We are an open community, not a closed. Anybody who wants to collaborate and input, and also when you have tools or anything else, we want to work with it. We are just a network. We have 450 universities in the meantime, but we're just a network that collaborates together, nothing else. But obviously with 450 universities, you have a manpower that I believe hardly few organizations can study. Then you have the organizational capabilities, a lot of them. And these are the capabilities you can develop, including smart marketing. Good. Then you also enable your service model. I'm not going to go through that. I'm just going to rush through it. Then I'm come to the information architecture. Now the information architecture, you saw each of them actually relating across. The reasons I did that is because for the subject tomorrow I'm going to talk about architecture. Because there is a layered architecture that needs to be considering all of the layers that we just discussed. How in the world is such a thing? But for an ontology you need to be considered. You can start at any point with any object that we just discussed. That's the whole thing about knowledge graphs. You have to be able to take whatever you want to center on and now focus on that. So, that's the same thing. The smart app, the intelligent personal assistant, the artificial intelligence apps. You have the smart app services. You have the big data. Now the data objects, and that's what I want to close with. And then my presentation is actually finished. Oh. That's the problem when you have so many things open. That's the one that's all these semantics I just told you about. That's all the study of those. Now I'm opening it. This is how it works. Content descriptions, layer, sublayer. So it's in the data is in the sublayer of information. Then it has a meta object definitions, and then all the semantic relationships. which by when you click on that, because it also, how does a data object include in a data table, which other things are in a data flow, and what defines a data flow, then you click on it and it goes to the next. Anyway, I'm sorry, I know I took a little bit over time, but I actually think I somehow managed it to that we finish on time. I think we went 6 minutes over, so that is it. I'm sorry, that's the short version of it. I'm sorry that I spoke so fast.
Thanks a lot, Mark. Really good. Thanks a lot. So actually, we will not have time for questions. We only have 35 minutes for lunch. Lunch will be served out in the arch.